This time we are going to discuss the exclusive NOR gate. Exclusive NOR gate is basically the combination of exclusive OR and inverter. Okay, like always, I'm going to start from the distinctive shape symbol. Okay, I'm going to draw the exclusive NOR, which looks very similar to the exclusive OR, but we're supposed to add the negation indicator, the bubble. And we have inputs A, B, and this is output X. Like exclusive OR, exclusive NOR is also produced with two inputs only. So, as I said, this is the combination of two gates, exclusive OR and inverter. Okay, exclusive OR not. So this is XNOR. Now we're supposed to also remember the rectangular outline symbol. Again, we have two inputs, A, B, and I have qualifying symbol, and I have also the polarity indicator. This triangle is representing the inverter. So this is the rectangular outline symbol. But most of the time we are going to concentrate on this kind of symbols. Next, we're supposed to remember the truth table of this gate. We have two inputs, that's why we are going to have four combinations. Okay, now, and let me get back to the exclusive OR. Exclusive OR gate had the truth table, which was saying that anytime the logic levels at the inputs are the same, output is 0, and when the logic levels at the inputs are different, output is going to be high. This is exclusive OR gate truth table. Next we have inverter. Inverter just has one input, and that's why we're going to have just two combinations, 0 and 1. And at the output, we're going to have complement of the inputs. So I'm going to have 1 and 0. So if you are going to find the complement of every single level at the output of my exclusive OR gate, I'm going to find the truth table of the exclusive NOR. So if again 0, 0, 0, 1, 1, 0, 1, 1. So this 0 is going to be converted to 1. 1 is going to be inverted to 0. This 1 is going to be inverted to 0, and this 0 is going to be inverted to 1. And this is the truth table for XNOR gate. Okay? So this is the truth table for this gate. If it comes to the logic expression, okay, for the exclusive NOR gate, we are going to have inputs A, B, for example, and this is output. And logic expression is A, exclusive OR, B, not. Why? Let's get back to this diagram. We have learned that the output of the exclusive OR gate is nothing else, just A, exclusive OR B. Now, if you are going to send this function to the inverter, at the output you are going to have basically complement of this expression. That's why the logic expression of the exclusive NOR gate looks like this, because this is the combination of exclusive OR and inverter. For example, if you have the logic expression, for example, K exclusive NOR B, for example. So this is nothing else, just the exclusive NOR gate with two inputs, okay, which are K and B. Now let's do some problems.